Our final section is our newest section. This is where we are solving systems of equations. Systems of equations means we're dealing with two or more linear functions in these cases for Algebra 1. But we look at the very first problem, number 29, and we're like, wait, that's only one line. Is the other one like up here somewhere or like way over there? I don't know. It's not. This is not tricking you that way. How this is tricking you is this is two lines. They're just the exact same thing. And whenever they're the exact same thing, that means you could pick an infinite amount of spots on that line, and it's always going to cross twice. Or not cross twice, but it's going to also be a point on both lines. Now, let's talk about the other special case for a moment here. What would no solution look like? Okay, no solution would be another line separate but parallel. That means they never cross. What does it look like when they actually do cross? What does that mean? Well, that's what we have on number 30. Number 30 is where we have two linear functions that have a single intersection point. That is what a solution is. So solution is just a, or not fancy, but a simpler word for intersection. Okay? That's what solution means. Here, these two lines intersected the entire time because they were the same. Okay? Here, they intersect one time. They intersect at -2 for the x value and +3 for the y value. -2, almost got me here. -2, +3. Number 31. This is where we actually get into the fun part of systems of equations. Okay, we're given the two equations and we have to find the intersection algebraically. Now, we just looked at a graph, so a lot of people might have graphing on their mind and might think, oh, let's graph this. But guys, this is set up as two equations in standard form, meaning it really should perk your ears and you should think, oh, this is one of those elimination problems. Now, you don't have to do it with elimination, but it's certainly the easiest way for most people here. So I look at how I'm going to make two of the coefficients on the variables. I need to make two of them, either these two or these two, the same number, but opposite signs. My first thought is to go after the x variables because they're already opposite signs. Then I look and I say, well, I can't turn a 2 into a 3, not by easy multiplication. So I've got to turn them both into the same larger number. One of the tricks is that you can usually just take these two numbers and flip it and multiply. But just think, what can I turn a 2 and a 3 into via multiplication? And that would be a 6. Well, how do I turn a 2 into a 6? I multiply by 3. Conversely, how do I turn a 3 into a 6? I multiply by 2. And I keep saying into a 6, but really this is going to be a -6, and that's what we want. We want same number, 6, 6, opposite signs, positive, negative. So when I do those multiplications, I get 6x plus 9y equals 54. I get -6x plus 14y equals -54. And I add my equations together and I eliminate the x's. Next, I have 23y equals, well, those actually kind of eliminated also, meaning our right side of the equation is a 0. This is where a lot of people panic and they're like, oh no, Mr. Strauss, something happened, something went wrong, I've got a 0. You're just not quite done yet. You can finish the problem up. Divide by 23, divide by 23. We get that y equals 0. So I look back up at my answers. That one's gone, I had y at 5. So I got rid of 1, but now I've got to finish the problem out by plugging this in. I'm going to plug in all the way up top to one of the original equations because I can still read them. Okay? 2x plus 3y. Well, we know what y is. It's 0. We just found that. Equals 18. That's going to cancel out. 3 times 0 is just 0. So I have 2x equals 18, meaning x equals 9. With these two pieces combined, we get that 9, 0 should be the answer. Option D. Number 32. So I'm going to clear out this one. If you need this, please pause for a moment if you need this work. Number 32 really can be done two different ways. I know you could do either of these problems with all three methods, but number two, really there's two good ways to do it. That would be substitution and graphing. Yeah, you could rearrange everything, put everything on the right sides and all that stuff and make it into an elimination problem, but most of us kind of stumble around with that a little bit. What you would do is you would move the 2x over and then line everything back up correctly and then run an eliminate. It's going to be complicated. Okay, what's not complicated is substitution. Because for substitution, our step one is isolate a variable. That's already done for us. Our next step was to take whatever was on the other side of that equal sign and plug it into our second equation. This time we plug in for y because that's what was solved for. So rewriting that bottom equation, 6x plus 3. We don't have y anymore. We have 2x minus 8. Notice, guys, again, just like we've been doing all semester, if you plug something in, use parentheses because now it's time to distribute. 6x plus 6x minus 24 equals 12. Please don't cancel these out. Positive 6 makes 12x. And when we add 24 and add 24, we see that 12x equals 36, meaning x equals 3. Scan the answers. Still in, out, out. So to figure out whether it's A or B, we must plug in this answer of x equals 3. I'm going to plug it in this top equation. It's the easiest one. Y equals 2 times x. We know x. We just found it. It's 3 minus 8. Y equals 6 minus 8. Y equals negative 2. Meaning our final answer should be 3, negative 2. And there it was. Now I said I wanted to look at this one two different ways, okay? Because it really would work out as a graphing problem as well. But most people look at this and they're like, Mr. How's this going to be a graphing problem? Because when we hop in the calculator, we look and we say, hey, we have to have y all by itself. Well, we have that on the first one. You can see I just have it typed in. 2x minus 8. But on the second equation, we don't have y all by itself. That's not that big of a hang-up. We're really good at solving equations. We've been doing it all year. And we're really, really good at solving equations for y because we've been doing it all year. Subtract 6x, subtract 6x. Guys, I got this weird habit where I just like to write the x first, where I just write negative 6x plus 12. Usually in class when I do that, I ask you guys, say, hey, why do you think I might do that? Someone spouts out for me, slope-intercept form or y equals form, and that's why. You don't need to do it that way. The calculator doesn't have to have it like this. What the calculator just has to have is y all by itself, so that's where our focus is. Okay? Divide by 2, divide by 2. We get that y equals, this is, again, the rocket science double division, negative 3x, okay, plus 6. Okay? Negative 3x plus 6. Oh, no. Oh, no. Oh, I made a mistake. I made a mistake all the way back at the beginning. This is a mistake that I always check for you guys. All right, first person that comes in tomorrow and says they found this part on the videos, you can have a jolly rancher. What was my mistake, guys? I didn't even write the problem down right. Oh, my Lord. I was looking at this and I was like, man, this isn't working out. I was just thinking ahead. I was like, this isn't working out the way I thought it was going to. Oh, my Lord. I didn't even write the problem down right. This should be a 3y. Oh, okay. Well, let's go on back a little ways. It's not going to change that much, but what I advise most of you guys to do is if you try to do a spot change of just one little piece of the equation, it's going to mess you up. So I just tell most of you to kind of just go back to the beginning. 6x. This is not a 2y. This is a 3y, so I'm going to have to speed this up a little bit. Okay. Again, we're going to subtract 6x. Same thing we were just doing. It's just going to change that last little step. 3y equals negative 6x plus 12. Divide by 3. Divide by 3, we get that y equals negative 2x plus 4. Ooh, I was about to mess everything up. I was about to mess up everything. Probably still mess some of you up. If that confused you, I apologize. Okay. This should be your second equation. So, negative 2x plus 4, and again, we are looking for an intersection point. Here comes line number 1. And here comes line number 2. They cross right here. You can eyeball it, 1, 2, 3, maybe negative 2-ish. But why leave it up to chance? Just hit second trace, number 5, enter, enter, enter,